So this next section is section 7.5 on complex numbers. What is an imaginary number? An imaginary number is the square root of -1, or what we call I. It's not a real number, it's an imaginary number, or we call complex number. If you go to your calculator and you try to put in the square root of -1, you get an error. There is no real answer, and therefore we have a complex number that represents the square root of -1, and it's called I. So I equals the square root of -1. If you square I, then you just get -1, because we would have the square root of -1 times the square root of -1, and the square roots would cancel one another out, and we would just simply be left with -1. A complex number is a number of the form A plus BI. Complex conjugate, A plus BI and A minus BI are complex conjugates. Number 1 asks us to show that -I times the square root of 19 is a square root of -19. Well, in order to show it, let's see. -I times the square root of 19, if we square that, do we get -19? That's what we're really trying to figure out. Well, let's see. When I square -I, I have -I times -I, and then I have square root of 19 times square root of 19. Well, -I times -I is I squared, because you have negative times a negative becomes a positive, and I times I becomes I squared. Square root of 19 times square root of 19 simply becomes 19. The square roots cancel one another out, and we're simply left with 19. I squared is -1, so this is -1 times 19, and we get -19. So sure enough, when you square -I times the square root of 19, you get -19. Here in number 2, we're asked to simplify. So I'm going to call this the square root of -1 times 40. And I'm going to pull out that -1 like that. Have my square root of 40. And I do need to simplify both of these. I know this first one is I, and then I need to think to myself, does 40 have any perfect squares? Can it be reduced? I think about my perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Can any of these perfect squares, is 40 divisible by any of those? Well, yep, by 4. So that becomes 4 times 10. And I get I, and I know that the square root of 4 is 2 times the square root of 10. Now I don't usually write I2 square root of 10, so I'm going to rewrite that as 2I times the square root of 10. Because the square root of 4 gave me the 2, still had the I, and the square root of 10 has to stay underneath the radical. Let's go to number 3. Number 3 says let W equal 1 minus 2I and Z equals 6 plus 9I. Express each in complex form. W plus Z. That means 1 minus 2I plus 6 plus 9i. Well, if I get my like terms together, 1 and 6 gives me 7. Negative 2i and 9i gives me 7i. Is in complex form. Remember, complex form is a plus bi. Let's go to letter B. W minus 3z. So I've got 1 minus 2i minus 3 times z, which is 6 plus 9i. I'm going to need to distribute the negative 3. And I get 1 minus 2i minus 18 minus 27i. Get my like terms together. First I get my real numbers together. 1 and negative 18 is negative 17. Negative 2i and negative 27i is negative 29i. Let's go to letter C. I'm asked to multiply w and z, so I've got 1 minus 2i times 6 plus 9i. I'm simply going to FOIL. 1 times 6 is 6. 1 times 9i is 9i. Negative 2i times 6 is negative 12i. Negative 2i times positive 9i is negative 18i squared. So let's start getting, let's do some simplifying here. I know I can get these together. I have 6, 9i and negative 12i is negative 3i. And then I've got to think about this. I squared is negative 1, which means this is actually negative 18 times negative 1. So this becomes plus 18. So I could actually have gotten the 6 together with the 18 and gotten 24. So this negative 18i squared was changed to positive 18. Just repeating this because I squared is negative 1. Negative 18 times negative 1 is positive 18. Let's go to letter D. 6 plus 9i times 6 plus 9i. Again, I'm going to FOIL. I get 36 for the first term, 6 times 6. Outer term is 54i. Inner term is also 54i. And my last term is plus 81i squared. Now, positive 81 times negative 1 actually makes this a negative 81. So when I go to get my like terms together, 36 minus 81, I get negative 45. And 54i and 54i is 108i. Let's go to letter E. W divided by Z. W is 1 minus 2i divided by Z, which is 6 plus 9i. Now, it'd be great if we could just leave this like this. However, since I is a square root, we have to rationalize the denominator. And the way you rationalize a denominator with complex numbers is you multiply the numerator and denominator by the complex conjugate of the denominator. Complex conjugate would be 6 minus 9i. But I've got to multiply it on the top and bottom so that I'm really just multiplying by the number 1. So now I'm going to need to FOIL the top, and I'm going to have to FOIL the bottom. 1 times 6 is 6. Outers is negative 9i. Inners is negative 12i. And the last term becomes positive 18i squared. On the bottom, I get 36 for the first. Outers, I get negative 54i. The inners, I get positive 54i. And the last is negative 81i squared. All right, start getting my like terms together. This plus 18i squared becomes minus 18. 6 minus 18 is negative 12. Negative 9i and negative 12i is negative 21i. In the denominator, this negative 81i squared becomes plus 81. 36 and 81 is 117. This is one way to write the answer. Another way to write the answer is negative 12 over 117 minus 21i over 117. The advantage to writing it this way is you can use your calculator to make sure you put everything in lowest terms. So I can do negative 12 divided by 117, and then do math, enter, enter, and it says, oh, this can actually be rewritten as negative 4/39. So that's good that I separated it like that. And then how about negative 21 divided by 117? Math, enter, enter. And I get negative 7/39. So minus 7/39i. Let's try another one. Let's go ahead and do this last one, w divided by z squared. W is 1 minus 2i divided by z squared would be 6 plus 9i times 6 plus 9i. Now, fortunately, I've already done this in a previous problem. Up here in letter D, I did 6 plus 9i times 6 plus 9i, and I got this. So I already know I can simplify to negative 45 plus 108i. But of course, I need to rationalize this denominator, so I have to multiply by the complex conjugate. Now notice in the complex conjugate, the a value doesn't change, it's only the b value. So it would be negative 45 minus 108i. Negative 45 minus 108i. So I'm going to need to FOIL. I can use my calculator to help me. So I'm going to FOIL the top. First term, I get negative 45. Outer term, I get negative 108i. Inner term, a negative times a negative is a positive. 2 times 45 I know is 90i. And then negative times a negative is a positive. We get 216i squared. Then I have the denominator. First term's negative 45 times negative 45. I used my calculator, I got positive 2025. Outer terms, 45 times 108. They're both negative. I'm going to get positive 4,860i. Inner terms, I'm going to get negative 4,860i. They cancel. That's what I wanted. And then a negative, positive times a negative is a negative. Let's see what 108 times 108 is. 11664.